Let us start our exact equivalent circuit, building of exact equivalent circuit. R naught and X naught we already modeled. R naught and X naught we already modeled, like no load current. So through this no load current will flow, and whenever the winding is carrying some current, automatically winding copper losses should be there. Okay, so winding will be like this. Through this winding, if some currents are flowing, so through copper wire some currents are flowing, which is having some resistivity and area of cross section of copper and length of copper. So definitely some resistance will be there. So depending upon the magnitude of resistance of the copper winding, definitely copper losses will be there. Okay, so in order to model those copper losses, actually copper losses are happening in a practical transformer. Those copper losses we are trying to model on paper. Okay, so on paper we have to model with that resistance only. So resistance, current is flowing through resistance, so I square R losses will happen here. Why I included this resistance? Because in practical transformer currents are flowing through practical resistance. Similarly in secondary winding also resistance will be there. Okay, now about leakage, actually leakage, like we may have to discuss lot many concepts about leakage, kind of like why leakage is, actually many people feel that leakage is lossy. Okay, or leakage influence efficiency. No, leakage is actually lossless quantity. Okay, so about this, like detailed course of machines I will discuss, but anyway keep one point in mind: leakage is not lossy, because leakage, if it is being modeled as an inductive reactance. Now normally an inductance, will it absorb any power? Will it absorb any energy? No. It will take the energy, store it, give you back. It will take the energy, store it, give you back. So leakage has been modeled in the name of inductance, means that it should be lossless only. Okay. Now you may ask me, like though it is like lossless, why you are modeling, or why you are focusing on leakage? Okay. Maybe down the line gradually you will understand. Okay. Leakage will influence all terminal response characteristics except efficiency. Okay, because leakage is lossless. But in efficiency calculations we need not bother about leakage, but voltage regulation will be there. Voltage regulation will be influenced by leakage. That's why we are modeling leakage. And maybe if you think of for a induction motor, okay, maximum torque or pull out torque will be influenced by leakage, or power handling capacity of the machine will be decided by leakage. Okay, so voltage regulation, speed regulation in case of motor, voltage regulation in case of generator, power handling capacity of the machine. So many things are influenced by leakage. That's why we are trying to understand leakage. But anyway, those things I will discuss in detail machine. Now it is machine simplified. So just like leakage is modeled in the name of inductance. Okay, so in exact equivalent circuit, like after R1 X1 my shunt branch will be there. Okay, now if I can move the shunt branch towards primary side, like shunt branch was here, ideally it should be here in exact equivalent circuit. In approximate equivalent circuit we can move the shunt branch from here to here. Okay, so if you already many of the students know this. Okay, but I know that many of the students don't know how it is being modeled or what are the implications of that. We will see in my detailed machine section. But anyway, to solve the problems of gate, this is more than sufficient. Thank you. We entered into testing of transformer now. Okay, basically this is the third phase of transformer, or third phase of any machine analysis. First phase is ideal machine analysis. We have done that, and we solved many problems there. And second phase is modeling parameter values, or developing or building equivalent circuit, means already we built it. Okay, and third thing is testing of transformer. In testing of transformer we have to find parameter values of equivalent circuit, like how much is winding resistance R1 R2, how much is leakage reactances X1 X2, how much is like R0 X0 values we have to find. Okay, now in order to find parameter values of equivalent circuit, like OC test and SC test is sufficient, but beyond that polarity test we are going to discuss. And about Sumner's test and like dummy load test, they are not giving questions, because even if they give question, solving that question is going to be damn easy. At the same time they have to give the diagram of Sumner's test or dummy load test completely. So that's why till now in GATE exam they did not give any questions from Sumner's and dummy load test. So I don't want to discuss that, because this is machines concised, simplified. Okay, in detailed course of machines I will discuss those things also. Okay, now coming to the point, first let me deal with polarity test. Okay, polarity test in the sense, like, in this way, if sense of the winding is known, if sense of the winding in the sense this particular winding is wounded in one direction, this particular winding is wounded in one direction. Okay, and in this case, like, primary is wounded in the same direction, but secondary winding direction is reversed. So sense of the winding. Now I have to tell one point here. Basically, if you know sense of the winding here or here, that will go to network theory, not in machines. Because in electrical machines, what will happen, like, is it possible to find sense of the winding for a practical machine? No. Is it possible to find, like, number of turns in primary or secondary in a practical machine? No. Basically, windings are preformed first. Okay, so first of all, if you see the winding, like, windings are preformed, in the sense first windings will be formed. First windings will be formed. Immediately after that, we are going to tape it. Taping will be done. Taping will be done. After that, we are going to provide some insulations here. Upon that, one lamination by one lamination we are going to insert. One lamination by one lamination we are going to insert. So in electrical machine, like, once a taping, like, once we will take the conductors and we are going to tape the number of turns, automatically finding number of turns for a practical transformer is not possible. Now, once the taping is done, okay, so once taping is done, once the winding is taped, like, how can you find number of turns, or how can you find sense of the winding? So in network theory, sense of the winding will be given. With sense of the winding is given, how to find polarities or how to find dots, it is going to be network theory. Okay, now without knowing the sense of the winding, without knowing the direction of the winding, how to find polarities, it's going to be our machine. But anyway, in, like, previous year's questions, some questions came along with sense of the winding also. Sense of the winding also. So that's why I'm forced to take sense of the winding also. But in a practical transformer, sense of the winding will not be known. Okay. Now coming to the point. Okay. This is, like, machines concised. Okay. So I don't want to discuss in detail everything. One thing, try to remember. Okay. If I am the limb, like, transformer limb. Now upon my limb, if wire goes, consider it as dot. Okay, for example, see here, this is the limb. Okay, so this is the limb. Upon the limb my wire is there. Keep dot here. Okay, so in these two, this is actually behind the limb. Okay, but this is upon the limb. Keep dot here. Enough. Okay, similarly here also, means limb is there upon the limb. Okay, let me repeat again. If I am the limb, if my wire is upon the limb and it is going like this, means that keep the dot here. And in this, like, upon the limb my wire is there here, keep the dot here. Okay, now why are we keeping the dots? Basically in AC, this is going to be AC voltage. In AC voltage, at one instant, if this is positive, because AC in the sense 0, positive max 0, negative max 0, so alternating. So whenever this is positive maximum, which terminal of this is going to be positive maximum? So this is going to be positive maximum. Okay, so whenever this terminal, because it is AC, for example, whenever this terminal is negative, this terminal is going to be negative. That's why we are keeping the dots. Now here also, if I keep dot here, okay, means that whenever this dot terminal is positive with respect to undotted terminal, this dot terminal will be positive compared to undotted terminal. Okay, this is more than enough. Okay, and here, like, in this few questions came, means immediately after this discussion I will take those questions and we will discuss. Okay, now coming to here, this is going to be my practical transformer. In a practical transformer, sense of the winding is unknown. So without knowing the sense of the winding, we should be able to find the polarities. Okay, in this, what do we know? What we do is, like, we don't know directly. By seeing, we cannot find the dots. So what I'm going to do is, let me connect this wire, short circuit, and let me connect 1 voltmeter. Okay, similarly here also, let me connect 1 voltmeter. Let me tell you, see, in a physical transformer, either this connection should happen or this connection should happen. Okay, so either this connection or this connection, there is no other possibility. So means here also in my practical transformer also there are two possibilities. If I keep the dot here, if I keep the dot in the upper section, dot here, either dot can be here or dot can be here. That's it. There are only two possibilities. Now, for example, if dot is here, for a practical transformer. Okay, so prior to conducting the test, we don't know the polarities, but for example, for a physical transformer, if these two are the dots, then what will happen? This is going to be, whenever dot is there, keep plus, undotted minus. Okay, and this induced voltage is E1, this induced voltage is E2. Okay, now apply KVL. Okay, so KVL plus E2 minus E1, so this voltmeter should read E1 minus E2. Now here if you see, for example, if the dots of a physical transformer are like this, okay, then what will happen means whenever you have the dot, keep plus. Whenever this is positive, this dot will become positive. Now this induced voltage is E1, this induced voltage is E2. Now try to apply KVL, means across voltmeter, E1 plus E2. Okay, what does it mean? Actually, prior to conducting the test, we don't know the voltmeter reading, but this voltmeter reading can be either this or this. So for example, if the voltmeter reading is like, this voltage minus this voltage, under that condition, across voltmeter terminals, keep the dots. Now, if your voltmeter reads E1 plus E2, under that condition, keep one dot at one voltmeter terminal, keep another dot at other than voltmeter terminal. Okay, if you keep the dot here and here, or if you keep the dot here and here, is going to be same. Okay, so if I keep dot here and here, or if I keep dot here and here, is going to be same. Okay, so in this way we are going to conduct polarity test and we will find the polarities. We will solve the problem soon. Let us deal few problems related to polarity test. These two problems are old civil services IAS questions. In this question, like in the given figure corresponding to transformer, two winding, voltage V1 across winding 1, the voltage V2 induced in across the winding. Very simple. See here, if we supply plus here, minus here, okay, voltage, because our normal that is our normal wave only, if it is plus minus, okay, normally we will represent in this direction the voltage V1. Okay, similarly here he represented, so this should be plus here, this should be minus here. Okay, now let me redraw this for better understanding. Okay, oh sorry, let me draw this from here to here. Okay, so here it is like behind the core, so like this. Okay, so as I told previously, if limb is here, upon the limb if wire is there, keep the dot there. So upon the limb wire is there, keep the dot here. Upon the limb wire is there, keep the dot here. So what does it mean? Whenever at one instant if this is plus, at the same instant this is going to be plus. Okay, by sense of the winding. Now he connected voltage here, so this is V1 they have given. Okay, so V1 in the sense plus minus. Now they have given from here to here V2, so V2 is given in this direction. Okay, in this direction means that this is going to be plus, this is going to be minus. With respect to this is at what potential? Okay, now V1 is like this, plus plus. So if E1 is like this, whenever dot is coming here positive, this dot should be positive. Okay, so in your network theory, this is going to be positive. Okay, actual positive. So by network theory, actually he is asking this, means that minus E2. Okay, so V2 is going to be minus E2. Minus E2 means that 180 degrees phase displacement will be there. So 180 degrees phase displacement will be there. Okay. In this question, I will discuss polarity test a bit more detail. Okay. Now, this is the transformer given. Okay, in this transformer, for example, plus is connected to here, minus is connected to here, AC source. So from plus, current has to come out. Okay, already you know network theory. In network theory, like you know, if any element is there, okay, this is going to be plus minus voltage, current is going to be like this. Then power absorbed is going to be V into I. Okay, you have to understand one thing here. Power absorbed is not simple VI, but rather it is voltage multiplied by current entering into positive terminal is going to be power absorbed. Okay, for example, what is power delivered by this? Voltage multiplied by current leaving positive terminal. Okay, so means voltage multiplied by current entering positive terminal of voltage is nothing but power absorbed. Okay, so now here, for example, if I connect the load here, we know the power flow. Okay, so how power flow will be? My source has to supply the power and my primary has to absorb that power, and that particular power should be transformed into magnetic field, and from there it has to absorb that from magnetic field, and my winding has to deliver the power, and this particular load has to absorb the power. Okay, so my direction of power is from here to here. Direction of power. So here my source has to deliver power. Okay, if current is entering into positive terminal, power absorbed. If current is entering from if current is leaving from positive terminal, it's going to be power delivered. So current has to flow like this. My current has to come out of positive, and you know right hand thumb rule. Okay, right hand only should be used. Right hand thumb rule, like you know, if this is the flux direction, this is going to be current direction, or if this is current direction, this is going to be flux direction. Anyway, we can use. Okay, now here see the sense of the winding. Sense of the winding is like this. So my current is entering here like this. My current is entering here like this. So my flux will be in upward direction. Now, for example, like you know, because of this voltage source, here power is absorbed, and that power is transformed into here magnetic field, and that will give you the induced voltage here. That induced voltage having the closed path for the current, so some currents will flow. Okay, so because of the currents in this particular winding, definitely flux should be produced, because whenever you have current, automatically flux should be produced. Okay, now means definitely flux has to be produced by winding pi 2. Okay, now for example, because of the current, flux is produced. Now I would like to know the direction of flux. How to find the direction of flux? Like you know, why pi 2 is created? Because Lenz's law, you know, anything created should oppose cause of its creation. Okay, but dimension should be same. Now why pi 2 is created? Because of some current here I2. Okay, this is pi 2 is in Webers and I2 is in amperes. Can pi 2 oppose I2? No. It has to find its parent in its own dimensions. Now why I2 is created? Because of induced voltage E2. Okay, now can pi 2 oppose E2? No. Now why E2 is created? Because of pi 1. Because of pi 1. So means my pi 2 found out its parent, that is pi 1. Again let me repeat, pi 2 is created because of I2, is created because of E2, is created because of pi 1. So pi 2 opposed pi 1. Now come to this side. Like you know, flux should be in this direction. My pi 2 should be in this direction. So my current should be like this. Okay, so my current should be like this. Means that see upper portion and lower portion. In lower portion only it can flow like this from behind the limb. So my current should be entering here I2, and current should be leaving here. Now my secondary winding has to deliver power and my load has to absorb. So it has to deliver power, means that my current has to come out of positive. Okay, now this is the thing. Now, let me start from starting. This is going to be V1. V1 has to supply power, and E1 should be like this, such that my current is entering into positive terminal, so power will be absorbed by primary. And pi 1, pi 2. Now from E2, my secondary winding has to deliver power, and my V2 has to absorb that power, such that my current is coming out of positive, so from secondary it is being delivered, and my load, means for the load, current is entering into positive, in the sense my load is absorbing power, we can say. Okay, now see the direction, see the given question asked, like he is asking the corresponding directions at the same instant of the secondary current I2 and secondary leakage flux pi 2 would be. Okay, now if you come back to here, my current direction will be like from here to here, my current direction. Okay, my secondary flux is in this direction. My secondary flux is in this direction means that my secondary flux pi 2 is in this direction, means that my leakage flux should be in this direction. Okay, so pi 2 is in this direction means that pi 2 leakage should be in this direction. So actually in the options given, means here some A is given, here some B is given, current is flowing from A to B, and here C is given, and here D is given, such that leakage flux is flowing from C to D. In this way we have to solve this question. Thank you. This is also a very beautiful question. Okay, two windings of a transformer are indicated by terminals A and B, and here across A and B they provided 100 volts. Okay, and with BD short circuited, they short circuited BD. Okay, and after that a voltage of 200 volts appears across AC. Here voltmeter is connected. This voltmeter is showing 200 volts voltmeter reading. The turns ratio from CD to AB, as we discussed, like there are two possibilities of sense of the windings. For example, if this is dot and if this is dot, okay, then in order to get 200 volts, how much should be this voltage? For example, means if this is dot, which is plus, and this is also dot, which is plus. Okay, now if I keep 300 volts here, now plus 300 minus 100, voltmeter reading is going to be 200 volts. Okay, or for example, if dot is here, this is going to be plus, this is going to be minus. Under that condition, my voltage is going to be aiding KVL, voltage rise. So in this case it will be 100 volts. Okay, now if it is 300 volts and sense of the winding, dot is here, voltmeter will read 200 volts. Or if dot is here and if this is 100 volts also, means voltmeter reading will be 200 volts. So in the first case 300 by 100, CD to AB 300 by 100 is going to be 3. Or in the second case, means CD 100, AB 100 is going to be 1. So turns ratio will be 3 or 1. This is